Hello, this video is a follow-up of my last video regarding the impedance topic we have discovered on the multimeter. I was thinking of that waiting for a fix. It is better to not use the auto mode setting anymore before the fix is applied. So it is better, I think, to use the manual modes, but now I was also discovering that the manual mode has also some strange behavior, and I'm referring then, let's say, to the 100 millivolt and the 1 volt. That's doing also some strange things if you are in an overload situation. Let me explain first the setup. So I have here a power supply. I have also a current meter which is able to have the range of micro ampere, while this one doesn't have that range. And let's say I want to have the manual mode, because auto you should not use. You put a 100 millivolt, and let's assume you make a mistake with the voltage. So here I have 32 volt, which is of course an overload situation, and I switch my power on. What will happen? Okay, you see here overload, and the overload is already gone. And what you see here is a drawing of 26 milliampere. 26, both are equal. That's fine. Of course, 32 volt is much more than 100 millivolt, but it doesn't say here overload, and that's a little bit strange. And also the drawing of the current is very high. If I switch to 10 volt, then you get the normal expected overload, and you also get a very low current consumption, 3 microampere. If you 3 microampere and 32 volts, that means that there is something of 10 or 11 mega ohm input resistance, which is fine, which is okay. But at the moment that you are doing a manual wrong setting, then it shouldn't give this value. The same applies if you go with 1 volt, then here it is saying overload. That's fine, that's nice, but what is not fine is that the current drawing is much higher than it should be. So this is something which I don't like, and that means that you should not use auto, but for 100 millivolt and 1 volt you have also take care about the side effects if you are selecting the wrong scale. With 10 volt, 100 volt or 1000 you have no problem, so you can use that easy without thinking, I would say. But yeah, it's strange. For illustration purposes, I want to show you how the measurement can be impacted due to the low impedance of the multimeter, or in overload condition or in auto. So I have made a very easy setup. I have here a power supply. I will give it a setting of 15 volt, and I will have my oscilloscope also connected to a capacitor which is empty. So I have here a capacitor of 470 microfarad, and the yellow trace, this probe, is connected to the capacitor, and you can see that there is 0 voltage at the moment on the capacitor. On the blue trace, only the power supply is directly connected, so that you can see the difference. So I will switch on the my power supply, and here we have 15 volt. With this probe, this is connected to the power supply, and if I give the capacitor 15 volt, you can see it on the oscilloscope. The yellow trace is following the blue one, so yeah, okay. If I remove it, and I will remove it, then you will see slowly a decrease of the yellow trace, so the voltage is dropping on the capacitor. The reason for that is that the probe, it is a ×1 probe, and that means 1 mega ohm. So slowly it is, you can see that it is slowly decreasing the voltage. But what happens when I'm connecting the multimeter on the capacitor? Now, I have here set on the manual 100 millivolts, and please watch. This is what you get. The discharge of the capacitor, as expected, is going very fast, very rapidly, because of the low impedance. Okay, let's do this once more. Again, I will switch on my power supply. And the blue trace 15 volt. I will charge the capacitor again to 15 volt. I remove it, the power supply, and the capacitor is going getting lower because of the impedance of the oscilloscope. But now I put it on, let's say 10 volt, and then I'm measuring again, and then you will see there's an overload condition there, but there is no strange effect because the impedance of the multimeter is high. So this is okay. If I'm going to set it in auto mode, and that's the reason why you should not use auto mode anymore, you will get this. Yeah, so you discharge in auto the capacitor very fast. This is just yeah, another way to see what the impact is of low impedance. So it is influencing your measurement on your device under test, and this is then a very simple one, but that's the reason why you should not use auto mode. The last thing I want to show to you is the trend view again. I have here my new Rigol 822 Pro version on my bench, and I have here a signal 100 millihertz with 2.4 peak to peak, and I have here, as you can see, the trend view activated, and you will see nicely the waveform from the waveform generator. So everything is fine and works as what you expect. The problem is a little bit at the moment that you increase and you are going outside the scale there, and you say I want to have 2.5 volt, so we are going beyond the manual setting I have set here. Then look to the screen, what is happening. You get overload, which is expected. On the top you see a flat line there, and then on the negative side you don't see a clipping here, but you see a clipping in the positive way, and that is also something which I don't like. The reason for that is that the overload, you see it shortly, there is no sign. It is always positive because he interpreted it as positive, and that's yeah, something which I don't like. So, if I go back to 2.4, no, then it will going away. Another thing which is a little bit strange is if you change the impedance of the multimeter, since we are in a 1 volt manual mode, and I put there, you see here the impedance is 11.2 mega ohm, but you can change it to a higher value, 10 giga ohm, which is good. You can do that for the 1 volt and 100 millivolt scale. If you put that on there, look what is happening. Yeah, this is a little bit strange also, because now the waveform is not in correct shape, I would say. So this brings me to the end of this video presentation. This will be my last one for this meter, because I'm shipping it back to the seller. The reason for that is because the impedance stuff, that is something which has to be fixed, and I know that it is hardware related. Rigol confirmed that it is indeed a hardware issue. They are working on it, so that means there is no software fix upcoming for that, and that will be the reason to ship it back, because I want to have a meter which you can use without thinking, because this is yeah, I cannot recommend this meter, of course. Nobody can, I would say, but it's up to you, of course. But I'm not happy with this, so I will ship it back. So I will make another video once I received an updated version and an updated hardware version, probably, as this one is still 2 months old. This is my second meter already. I had an E version first, but this one, oh wait a moment, make a wrong system, and then about 101, so I guess 101 is not good. It should be higher than that, but let's wait and see. Also, there are some software bugs as well, but I didn't bother to make a video about that, so that will be maybe also a next video if I have received another version back. So if you want to be informed, yeah, please subscribe to my channel, and if you like the video or thinks it is useful, please give me a thumbs up. And yeah, now I hope I will see you in let's say a month or something, when I have a new digital multimeter, or a repaired one, let's say. Thank you, and bye bye.